Now let's think more about the lines actually living in three-dimensional space and how they might interact with each other. So if we think back to lines in the xy plane, there's basically two options. If we have two lines in there, they either intersect each other, so something like this, or they're parallel. So these are basically our two options in the plane, in the xy plane when we're graphing lines. But we actually now have another option. In three-dimensional space, we can have two lines be what is called skew, right? So if you imagine my arms here are lines, that's a line. One might look like this, the other might be going off like this, right? So they're not parallel to each other, but they also don't intersect. And this is a feature of this new extra dimension we have. You can kind of just imagine taking these intersecting lines, grabbing one of them, and kind of pulling it up a little bit. That would be examples of skew lines. So a way to try and draw that might be something like, maybe we'll leave a little break here to say that one line's going underneath the other one. All right? So how can we check these properties? So parallel, as you know, when we're trying to say whether two lines are parallel in the xy plane, we looked at their slopes and said if they're the same, then the lines are parallel. Well, in three-dimensional space, we don't really have slopes so much as a direction vector. So parallel, the way we check this is they're parallel if they have the same direction vector. How do we check if two lines intersect? Well, if we want to check for intersection, we need to have a way to write down both lines. So let's say the first line is R1 of t, and the second line is R2. Instead of t this time, we're just going to change it to s. Right? So I just need another parameter that I can use separately. Right? And if these two lines intersect, then we can solve the equation R1 of t equals R2 of s. Okay? This is how we can check whether two lines intersect. So if you think back to, I guess this would be maybe pre-calculus or intermediate algebra, algebra 2, if you remember how these two things look, we really get a system of three equations, but only two variables. So it's what's called overdetermined, which means there might not be a solution. And if there's not a solution to this, then we're in the skew case. So this one is when R1 of t equals R2 of s has no solution. Right? Okay, so let's do an example of what we were just talking about with actual lines. We have here given to us as parametric equations two lines, L1 and L2. And we want to figure out whether the lines are parallel, skew, or intersecting. Okay. So the easiest one to check for first is parallel. Right? We just have to see, do they have the same direction vectors? Well, if you remember from how parametric equations are set up, the coefficients of t tell us the direction vectors. So let's say the direction vector of line 1, let's call it v1. Well, that would be 2, -1, and 3. Right? We can also have the same thing, but for L2. This vector we'll call v2. And this is going to be 4, -2, 5. Right? So if the two lines have the same direction, meaning they're parallel, that means their direction vectors need to be parallel. Right? We don't actually need the vectors to equal each other, but they do need to be parallel to each other. So, well, are these vectors parallel to each other? So if they are parallel, that means we can multiply one of them by some constant and get the other one. So if we look here, there's a 2 and a 4 in the I components. So if we multiplied the first vector by 2, the I components match. And actually the J components match as well, because we would get -2 and -2. However, when we multiply 3 by 2, we get 6, which isn't the same as 5. So that tells us these vectors aren't parallel. V1 is sort of not parallel. Maybe that's a good way to write it. So not parallel to V2. Let's just write in parentheses here. These are not parallel. Right? So that means the lines aren't parallel. So what do we do now? Well, we have two remaining options, skew or intersecting, and we have to try and solve for that. Okay, so they weren't parallel. That means we need to check one of these other things, and that was setting this line equal to this line. Right? So in the vector notation for the lines, that was r1 of t equals r2 of s. Right? In the symmetric equations, we just have to set the x components equal, the y components equal, and the z components equal. So here we've already written L2 with an s instead of a t, but if this was given to you with a t instead of an s, you would have to change them. You would have to say if this were 1 plus 4t, 3 minus 2t, 4 plus 5t, you'd have to change it to what you see here, or some other letter other than t. So let's actually try and determine now whether they're skew or intersecting. And that's just by setting their components equal to each other. So 3 plus 2t, that had better equal 1 plus 4s. 4 minus t is 3 minus 2s. And 1 plus 3t equals 4 plus 5s. Right? So remember, if we can solve this, the lines intersect. If we cannot solve it, the lines are skew. So let's actually work on solving this now. So what we're going to do is move all the t's and s's to one side, and then the rest of the stuff to the left. Right? So in this first equation, we'll get 2t minus 4s is minus 2. Okay? This one, we're going to move the negative 2s over. So we'll have negative t plus 2s equals minus 1. And finally, this last equation here, we'll move the 5s over. So 3t minus 5s. And this will be equal to 3. So let's look at this equation here. I know we just kind of moved the s over, but it's very easy to solve for t in this equation because it's by itself. And that is a minus t. Hopefully you can see that. Right? So let's isolate the t in this. So we don't have to think about, oh, we have to move the 2s back. Let's do this. Let's move the t over here and the minus 1 over here. So that gives us 2s plus 1 equals t. Right? So now what we're going to do is take that equation for t and plug it into one of these other two. Doesn't matter which one. Let's use the first one. So we're going to take this and put it in there for t. So when we do that, we get 2 times 2s plus 1, right, minus 4s equals negative 2. Okay. So let's expand this out or multiply this out here. We get 4s plus 2 minus 4s equals negative 2. Well, these cancel, and we end up with 2 equals minus 2. That's not really true. That's not very good. So what does that mean? That means the equations can't be solved. And since they can't be solved, or there is no solution, that means our lines are skew.